All right, so DeepSeek V4 Pro just scored 91.2% on Zowie Bench, while Gemini 3.6 Flash landed at 49.6% on that same eval. That's nearly double the score, and it shifts the whole conversation about which model you should actually be running. I ran both models through 4 real tests: coding accuracy, API cost, response latency, and context window fidelity. Every number here comes from verified sources, no vendor marketing dressed up as data, and your output bill at scale could swing by thousands of dollars depending on which one you pick. Honestly, I thought this was going to be a clean sweep for DeepSeek. But one number buried in the context fidelity data made me rethink putting it anywhere near a customer-facing surface, and that flips the conditional verdict in a way I wasn't expecting. This comparison is for developers and teams picking a model for production workloads right now. If you're running 10 million output tokens a day, the cost gap between these two works out to about $66 a day every day. That's the kind of number that makes or breaks a unit economics decision. So let's get into it. Test 1 is multi-step coding accuracy. Picture this: you send the model a real GitHub issue, it produces code that looks right, passes a surface level read, and then breaks in staging. You've now burned hours of engineer time debugging something the model confidently got wrong, and that's a very concrete cost when accuracy falls apart. I looked at Zowie Bench Verified, which uses real GitHub issues, not toy problems. DeepSeek V4 Pro came in at around 91.2%, and Gemini 3.6 Flash at 49.6%. What surprised me is how wide that gap is. Bear in mind, these are different test harnesses, so treat it as directional, but you're looking at roughly double the resolution rate on the same class of task. Now, take this with a grain of salt. DeepSeek V4 Pro timed out on 9 of 38 tasks in one independent benchmark, which is a real reliability flag. And Gemini's 49% DeepSWE score came with 65% fewer tokens used, so it's doing more with less even when the raw number looks worse. The gap is real, but it's not the whole story. DeepSeek V4 Pro takes test 1. I was expecting a close race on coding given Gemini's efficiency angle, but 91.2% versus 49.6% on SWE Bench isn't close at all. That's a gap you can't explain away with token efficiency, so that's 1 for DeepSeek V4 Pro, 0 for Gemini 3.6 Flash on the scoreboard. Test 2 is API cost per million tokens. You build a prototype, it feels affordable, you scale it up, and then the bill arrives and it's 8 times what you modeled. Output tokens are the sneaky one because that's where the real spend hides, and most people don't stress test that number until it's too late. What I found here was pretty wild. DeepSeek V4 Pro runs at $0.435 per million input tokens and 87 cents per million output tokens. Gemini 3.6 Flash is $1.50 input and $7.50 output. So that output gap is 8.6 times more expensive. Even after you account for Gemini's 17% token efficiency improvement, DeepSeek still wins on per task economics for almost every workload I looked at. DeepSeek V4 Pro wins test 2. And honestly, this one wasn't close either. I expected Gemini's token efficiency to close the gap more than it did, but at 8.6 times cheaper on output and 41 times cheaper on cached inputs, the math just doesn't move in Gemini's favor. That's 2 for DeepSeek V4 Pro, 0 for Gemini 3.6 Flash. Test 3 is response latency under load. Think about a user-facing app where the model is too slow to stream a response and the user just sees a spinner. At some point, that spinner costs you a conversion, a support ticket, or a churn event, and throughput speed stops being abstract really fast when it's sitting between your product and your user. I looked at the throughput numbers, and Gemini 3.6 Flash came back at around 304 tokens per second versus DeepSeek V4 Pro's 75 tokens per second on the standard API, which is roughly 4 times faster. DeepSeek can hit 167 tokens per second via Fireworks, but that's a premium provider at higher cost, so it's not a fair comparison to the base API numbers. Now, these are different measurement setups, so treat the 4 times figure as directional rather than a controlled head-to-head. Both models also have community-reported reliability problems. DeepSeek has consistent timeout issues in Warp Terminal, and Gemini users flagged random latency spikes with no explanation from Google. Neither company publishes clear SLA documentation, which is kind of a problem if you're building anything production grade. Gemini 3.6 Flash takes test 3. I was expecting DeepSeek to be slower, but 304 versus 75 tokens per second is a bigger gap than I thought it'd be, even accounting for the different test setups. For streaming apps, that gap is real and it matters. So the score sits at 2 for DeepSeek V4 Pro, 1 for Gemini 3.6 Flash. Test 4 is context window utilization fidelity. You're running a SQL schema through a million token context, the model hallucinates a column name, and that bad data hits your database. You don't catch it until something downstream breaks in a way that's really hard to trace back. And that's what happens when a model confidently answers instead of saying it doesn't know. What surprised me most in this whole comparison was DeepSeek V4 Pro's 94% hallucination rate on AA omniscience, meaning it almost never says it doesn't know. it just answers. Gemini 3.6 Flash has no published figure there, so I can't do a direct comparison, but that 94% number is a serious production risk flag I wasn't expecting to find on a model that scored so well on coding. So this one's genuinely complicated. Both models support 1 million tokens, but they fail differently. DeepSeek V4 Pro can output up to 384,000 tokens per call and scores 83.5 on MRCR retrieval, but that hallucination rate is scary. Gemini caps output at 65,000 tokens per call, which rules it out for single call full code-based generation, but it handles images, video, and audio natively, which DeepSeek just can't do. This one's a tie, and honestly, I was expecting a cleaner result. DeepSeek wins on output ceiling and retrieval scores. Gemini wins on multimodal breadth, and that 94% hallucination rate on DeepSeek's side is too big a caveat to hand it a clean win. So the scoreboard sits at 2 for DeepSeek V4 Pro, 1 for Gemini 3.6 Flash, 1 tied. So where does DeepSeek V4 Pro clearly win? Coding accuracy isn't even close at 91.2% versus 49.6% on SWE bench. API cost is brutal for Gemini. Output tokens are 8.6 times cheaper. And if you need to generate a full code base in a single call, DeepSeek's 384,000 output ceiling versus Gemini's 65,000 cap makes it the only real option. Now, where does Gemini 3.6 Flash clearly win? Speed, 304 tokens per second versus DeepSeek 75, which is about 4 times faster for streaming apps. Token efficiency, 17% fewer output tokens on average, 65% fewer on agentic coding tasks. And multimodal context, images, video, audio, and PDFs all in 1 million tokens, which DeepSeek just cannot touch because it's text and code only. Okay, so here's the honest conditional verdict. I went in thinking DeepSeek would be the obvious pick across the board, but that 94% hallucination rate changes the calculus for anything customer facing. So if you need coding power and cost efficiency at scale, DeepSeek V4 Pro is the clear choice. And if you need fast streaming responses or multimodal context, Gemini 3.6 Flash is the one. Full stop.